Greetings to all. I am Dr. G. Saktivel, Assistant Professor, Department of Electrical and Electronics Engineering, Kamaraj College of Engineering and Technology. In this video lecture, I am going to discuss about choppers and the types of choppers in detail. First, what is a chopper? Chopper is a static circuit that is used to convert fixed DC to variable DC. Nowadays, we are using various DC applications that are require variable DC supply, and we can get variable DC supply from the fixed DC. For that purpose, we are using chopper circuits. So, the main applications where we are using choppers are, one is subway cars and the second one is battery operated vehicles. And by using chopper we can get variable DC. So, as I said earlier, the choppers are classified as step up chopper or step down chopper. There are two types. In the classification of chopper there are two types, one is step up chopper and the another one is step down chopper. In the step up chopper the output voltage is higher than the input voltage, whereas in step down chopper the output voltage is less than the input voltage. Now, we are going to discuss about the types of chopper, the circuit diagram and the relevant waveform and their working of the types of chopper. First, we are going to discuss about the step down chopper, that is the output voltage that is less than the input voltage. That chopper is said to be step down chopper, and I am considering the case Vs as the input voltage. This is the input voltage and V0 is the output voltage across the load, and here this is the circuit diagram for the step down chopper. In this step down chopper the circuit consists of a chopper, this is a chopper circuit, and this chopper circuit which may consist of a switching device, either it may be an SCR, MOSFET or it may be an IGBT. So, it consists of a diode and it consists of an inductor and the load, and this is the circuit diagram for step down chopper. And in general, whenever the chopper is on, the chopper is in on state, this is the first state. Whenever the chopper is on, at that time the switch is closed and the current will flow through the inductor and then to the load and then to the negative terminal, and it will start from positive terminal and then to the switch, and the inductor will store the energy and then to the load, and at that time I am getting the output voltage V0 during on time period 0 to t on. The output voltage will be equal to my supply voltage Vs. And next second case, whenever the switch is turned off, suppose if the switch is turned off and then it will be, the load will be disconnected from the supply, and at that case the terminals across the load are shorted. Whenever the chopper is in off state, at that time the load terminals are shorted. So, what will happen if the load terminals are shorted? Then the output voltage V0 will be equal to 0. This is the off time period. During this time period the output voltage V0 will be equal to 0. V0 will be equal to 0. And in this particular case, whenever the chopper is on state, the current will start to increase from the limit, lower limit I1, and it will increase to the maximum limit I2. Once the maximum current is reached, then the chopper circuit will be turned off and the current will start to decrease, and it will again reach to the lower limit I1, so that we can maintain the current limit within this circuit. And this is the derivation for finding the average output voltage. I am going to find the average output voltage for this step down chopper. The average output voltage can be calculated for the total time period 0 to t. So, t is the total time period, that is the sum of on time period plus off time period. So, 1 by t into 0 to t on, and up to this instant the value of output voltage will be equal to Vs, and the time period during the off time period the output voltage will be equal to 0. So, I have neglected this term, and integrating this I am getting this expression Vs into T on divided by T, and I am introducing the another term, that is alpha, that is otherwise named as duty cycle, and this alpha can be found out by dividing the two terms, on time period divided by the total time period. Consider a circuit diagram for a step up chopper, and it consists of a supply voltage Vs, inductor, and then this is the chopper, that is a static circuit, and a diode, and then the load. And here consider this case, during the instant the chopper is in on state, that is the switch is closed, then what will happen to the output voltage V naught? At that case, whenever the switch is closed, then the current will flow through this circuit, through this loop. From positive terminal the inductor will store the energy, and then to the switch, and then to the negative terminal of the supply, and so that the output voltage V naught will be equal to 0. There will not be any output voltage across this load, and whenever the chopper is in off state, at that time the supply voltage, already the inductor that is present in the circuit stored some of the energy, and that energy will be equal to the supply voltage. That is, whenever during the instant the on time period, at that time the available voltage across the inductor VL will be equal to Vs, and during the off time period the voltage that is available across the load will be equal to, that is V naught will be equal to the supply voltage plus the energy stored in the inductor, that is taken as VL. So, I am getting an additional voltage that is stored in the inductor. The energy stored in the inductor is I am getting in the output voltage across the load during the off time period. So, I am going to find out calculate the energy during the on time period. So, whenever the chopper is turned on, at that time how much energy is stored in the inductor. So, in general the energy can be calculated by the product of power into time. So, how can we calculate the power? So, power can be calculated by voltage across the inductor and the current that is flowing through the inductor into on time period. So, that will give us the energy that is stored in the inductor. So, I am considering this case. So, during on time period the voltage that is available across the inductor will be equal to the supply voltage, and the current will be, there are two limits, one is the lower limit is taken as I1 and the upper limit is taken as I2. Between these two limit the current level is maintained in the circuit. So, I am considering the average. So, I1 plus I2 into 2 into T on. I am going to calculate the energy that is released by the inductor during the off time period. So, during the off time period the energy can be calculated by the same formula, product of power into time. So, the power can be calculated by the voltage across the inductor into current into off time period. So, the voltage across the inductor will be calculated by, so using this relationship. So, V naught will be equal to Vs plus VL. So, I am going to find out the value of VL, that will be equal to V naught minus Vs. V naught is output voltage, that is the voltage that is available across the load, and Vs is supply voltage. So, by subtracting the supply voltage from the output voltage, I am calculating the value of voltage across the inductor, and the current is average value into off time period. So, I am this is mentioned as equation 1 and this is mentioned as equation number 2. So, I am considering one particular case, the system is lossless, both the energies are equal. So, I am equating these two terms. So, Vs into I1 plus I2 by 2 into on time period will be equal to the equation number 2, that is V0 minus Vs into I1 plus I2 divided by 2 into off time period. So, substituting and equating, I am getting this equation. So, Vs into T on is equal to V0 into T off minus Vs into T off. So, by equating these two terms, I am having the parameter Vs as common. So, I am bringing back this term Vs into T off into left hand side. So, Vs into T on plus T off will give you the equation V0 into T off. So, this is the final expression that I am getting. So, I am further simplifying further. So, V0 into T off is equal to Vs into T on plus T off. In general, the on time period plus off time period will give us the total time period, T is equal to T on plus T off. So, V0 is equal to Vs into T by T off. This is the final expression that I am getting for the input voltage and output voltage, but I am in need of the to build a relationship between V0, Vs and alpha, that is duty cycle. So, I am going to find out. So, I am rewriting this T is equal to T on plus T off. I am going to find out this T off. So, T off is equal to total time period minus on time period. I am bringing this here. So, the equation becomes Vs into T minus T on. So, further simplifying, taking the T as dividing the term numerator and denominator by T, I am getting this expression Vs into 1 by 1 minus alpha. So, suppose if the value alpha is 0, consider this case, suppose if I am putting alpha as 0, then V0 will be equal to Vs. Suppose if my input voltage is 10 volt and the alpha value is 0, then the output voltage will be equal to 10 volt. Suppose if I am changing the value of alpha as 1, the ratio, that is T on by T as 1, then the value of V0 will be equal to infinity. So, this is the general observation, and in more specific, by varying the value of alpha between these two ranges 0 to 1, I can get variable output voltage. Consider this case, the input supply voltage is 10 volt and I am maintaining the ratio, duty ratio as 0.5 as the first case. Suppose if the ratio is 0.5, then the value will be equal to output voltage will be equal to, I am substituting this Vs as 10 volt and alpha as 0.5. So, I am getting V0 as 20 volt. So, Vs is 10, 1 by 1 minus 0.5, that is 1 by 0.5. So, 10 by 0.5 will give us 20 volt. So, in similar, I am changing the value as alpha as 0.75, then maintaining the input voltage as 10 volt. So, 10 into 1 divided by 1 minus 0.75, so 1 by 0.25. So, 10 divided by 0.25, I am getting 40 volt. So, what we infer from here is, by varying the value of alpha between these ranges, I am getting the voltage, that is the output voltage V0 is higher than my input supply voltage. So, this type of circuit is step up chopper, the output voltage is getting maximum, whereas in step down chopper the output voltage is less than the input voltage. Thank you.